Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through parallel and perpendicular lines. So let's start off by graphing the line y equals 2x plus 1. I know you know how to graph that from a previous lesson. So remember, this number here is the y-intercept, which we've called b, and this number here is the gradient. In order to graph this, what I do is mark the y-intercept, and then I use the gradient to find a second point. So a gradient of 2 means I go 1 to the right, and then I go 2 up. So another point is here at 1, 3. And of course, once I have those 2 points, I simply draw a line through them. And so the line y equals 2x plus 1 looks like this one here. So now let's graph in red the line y equals 2x minus 5. Well, that's going to be very similar, except the y-intercept is now minus 5. Now, because the gradient's still 2, we're still going to go across 1 and up 2. So we will also go through this point here. So I just mark this point and draw a line through. So the line y equals 2x plus 5 will be this line here. Now both of these lines have the same gradient of 2. That means they have the same slope and they're going in the same direction. So what will happen is, it's like the red line is always 6 lower than the blue line. So if you have a point on the blue line, you always go 6 down and you'll get to the red line. Point up here, go 6 down and you'll get to the point on the red line. So these two lines will never actually meet or intersect. They will never hit each other. And that's because they have the same slope and are going in the same direction. So it turns out that two lines are parallel if and only if they have the same gradient. So the way we write that in shorthand mathematical notation, we write m1 equals m2. So that means gradient of the first line equals gradient of the second line. If the gradient of the first line equals the gradient of the second line, then the two lines are parallel. But if we are asked whether or not two lines are parallel, we don't always want to graph them like we did here. I did that just to show you what's going on. Graphing takes a long time. So if we are to determine whether or not two lines are parallel, we only need to look at their gradients. So let's say we're asked, are the lines y equals 3x plus 6 and y equals 4 plus 3x, are they parallel? Will they ever meet? So rather than graphing this and graphing this, which takes too long, we're just going to look at the gradients. So remember, when the equation of the line is written in the form y equals something, the number in front of x is the gradient. So for this first line, 3 is the gradient. m1 is equal to 3. For the second line, it's written a bit differently. It's still in the form y equals something, so that means if it's written in that form, the number in front of x is the gradient. So it turns out m2, gradient of the second line, is 3. Both these lines have the same gradient. So I can conclude without graphing that yes, they are parallel. If I were to graph these two lines, they would never meet. Let's look at these two equations here. Well, clearly the gradient of this line is the number in front of x, which is 5. But the second one's a little more difficult. See, this one is not in the form y equals, so we can't say that the number in front of x is the gradient. In order to know the gradient of this line, we need to rearrange it so it's in the form y equals something. So what I would do to this equation to get y by itself is I'd subtract 5x from both sides, and I'd get y equals 10 minus 5x. Now it is in the form y equals something. So the number in front of x is the gradient now. So the gradient of the second line is actually minus 5, not positive 5. So these two lines actually don't have the same gradient. So I can tell without even graphing them that no, they will not be parallel. In other words, these two lines will actually meet at a point. Alright, I'm going to rub this off. Please pause and copy down if you need, and we'll look at perpendicular lines. So now let's graph these two lines on your screen, y equals x minus 1 and y equals 1 minus x. So to graph this top line here, so it has a y-intercept of minus 1. Now, because no number's written in front of x, it's the same as a 1, because x and 1x are the same. So this line actually has a gradient of 1, so I'd go across 1 to the right and up 1. It'd go through this point here, and then I just join them up. So let's now graph this line y equals 1 minus x. Well, it has a y-intercept of positive 1. Its gradient, however, is negative 1. So that means I go across 1 to the right, but instead of going up, I'm going to go down 1. It turns out it also goes through this point here. And so once again, now that I have 2 points that the line passes through, I just draw a line through them. So in red, we have the line y equals 1 minus x. Now these two lines are clearly not parallel because they intersect. It turns out that they intersect at right angles, and the word we have for that is perpendicular. These two lines are perpendicular to each other because they intersect at right angles. So it turns out that the reason these two lines are perpendicular is because their gradients multiply to minus 1. Another way to say that is the gradient of the first line times the gradient of the second line equals minus 1, or equivalently, gradient of first line is minus 1 over the gradient of the second line. So up here, we saw the gradient of the first line was 1, the gradient of the second line was minus 1. If I multiply together the two gradients, I get minus 1. That's what it means for two lines to be perpendicular. So once again, we can tell without graphing whether or not two lines will be perpendicular. So let's check whether or not these two lines will be perpendicular. So if I were to graph these two lines, it'd take a while. I'll have to use XY intercept method. Instead, I'm just going to find their gradients. So as I said in the previous example, we can't find the gradient just by looking at either of these two lines. It's not in the form y equals, so the number in front of x isn't the gradient. To find the gradient, I need to rearrange each of these so they're in the form y equals. So for the first one, what I'm going to do is subtract 3x from both sides, and then to get y by itself, divide each side by negative 5. So 15 divided negative 5, and then I go negative 3 divided by negative 5 gives me a positive. So the gradient of this first line is 3 over 5. So what about the second line? Well, here we're going to subtract 5x from both sides, then divide each side by 3. So 30 divided by 3 is 10, minus 5 divided by 3. So the gradient of this second line here is minus 5 over 3. So, these two lines are clearly not parallel because the gradients are not equal, but are they perpendicular? All we need to do is check, does the product of their gradients equal minus 1? So, first gradient times second gradient. The first gradient was 3 over 5. The second gradient was minus 5 over 3. So, if you put that on your calculator, you get minus 1. Because this gradient times this gradient is equal to minus 1, the two lines must be perpendicular. I can tell without even graphing. All right, the last thing we need to do on this video is use parallel and perpendicular lines to find the equation of a line. So now we're going to look at finding the equation of a line. So it turns out the equation of any line can be written in the form y equals mx plus b. So all we need to do is find m, which is the gradient, and then find b, which is the y-intercept. So let's look at two examples. So let's do these two examples here. So first we'll find the equation of the line parallel to this line that passes through minus 4, 2. So we need to find the gradient of the line. Now because it's parallel to this line, it will have the same gradient as this line. So to find the gradient of this line, remember we need y by itself, so all we need to do here is subtract 2x. The gradient of this line, at 2x plus y equals 3, is minus 2. So that means the gradient of any line parallel to it will also be minus 2. So step 1 is done. So step 2 says I need to find b, the y-intercept of this second line. So what I do is I take my equation y equals mx plus b, and I substitute. So I'm going to substitute m for minus 2, which I just found. Now to substitute x and y, I take that from the point. This is the x value, this is the y value. So I'm going to change x to minus 4 and y to 2. So now I simply solve this equation. So minus 2 times minus 4 gives 8. So 2 equals 8 plus b. Subtract 8 from both sides, you get minus 6 equals b. So the equation I'm looking for is y equals mx plus b. These two lines are parallel, and this line goes through that point there. Okay, let's look at this example here. So I want to find the equation of the line perpendicular this time to 4x plus 3y equals 12 that passes through this point. So my first step is I need to find the gradient of this second line. So the gradient of the first line is found by rearranging it. So I'm going to rearrange it by subtracting 4x and then dividing by 3. So the gradient of the line that I was given, if I divide 12 by 3, I get 4, and dividing minus 4 by 3 as well. The gradient of this line here is minus 4 over 3. So if a line is perpendicular, I find its gradient using the formula on the previous slide. It's just minus 1 over the gradient of the other line. So if you put that on your calculator, you get 3/4, because 3/4 times minus 4 over 3 gives minus 1. And if the two gradients multiply to minus 1, then they're perpendicular. So if you know the gradient of the first line, just minus 1 divided by gradient of the first line, that will give you gradient of the second line. So we've done step 1 and found the gradient of this line that's perpendicular. Now we're going to find b exactly as we did in the previous example. So I'm going to take my equation y equals mx plus b. We're going to substitute. This time m is 3 over 4. And once again, x and y come from the point. So in the point 8, 1, x was 8 and y was 1. So substituting this in, we get 1 equals 3/4 times 8 is 6. 1 equals 6 plus b. I want to get b by itself, so I subtract 6 from both sides and get minus 5 equals b. So the equation of the line perpendicular to this line that passes through 8, 1 is just simply going to be y equals mx plus b, and then we're done. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.